Alright, so we'll talk about arc length, area of a sector, and then converting between linear and angular speed. So we learned that a radian is equal to the arc length divided by the radius. So then what we can do with that is to solve for the arc length, and so the arc length will be r theta. We also have, and that's the formula for arc length. We also have area of a sector, and that's area equals 1/2 r squared theta, which is that's area of a sector. And remember that arc length is, if we have a theta, then arc length is the length of the arc around the circle, and then if we had a sector is going to be the area of that part of the circle. Alright, so find the arc length if the radius is 2 feet and the angle is 100 degrees. One more thing, we can't use this formula, we can't use either formula unless theta is in radians. So we know we're dealing with something like this, where theta is 100 degrees. We're going to find the length around the circle of a radius 2. So arc length equals r theta. R is 2, and then we are going to multiply by theta, but we don't want to multiply by degrees, so we will cancel the degrees and convert to radians. And if we do all that, we get about 3.49 feet, which would be the length of the arc. Okay, pause the video and try this one. And if we multiply everything out, we get 14.137 inches. So now we know the arc length and the radius, then we'll solve for theta. Arc length is 10, the radius is 7, so we know that theta is 10/7 radians. Then we could convert that to degrees, 10 over 7. That's radians, so we want to cancel radians. Pi radians, 180 degrees. And if we multiply that, we get about 81.85 degrees. All right, pause and try that one. (20 over 8 radians, or reduced by 4, and we get 5 over 2 radians. And we could convert that to degrees. 5 over 2. We need to cancel the radians, multiplied by degrees. We get about 143.24 degrees. Area of a sector is 1/2 r squared theta. 1/2 r squared theta. Has to be in radians. That's in meters, so we have square meters. Pause the video and try that one. All right, so that's arc length and area. Now we're going to use arc length to find angular and linear speed. So let's talk about linear speed. Distance over time, we're familiar with that. And angular speed is the size of the angle divided by time. We can also say it's revolutions divided by time. And a common variable for linear speed is v, and a common variable for angular speed is omega, which is a curved W. All right, let's think about this. So if we can understand what's happening here, then this is just talking about distance, but if then we take this distance and divide it by the time it takes to do this, then now we can talk about speed. So if it's 27-inch diameter, we can, in one revolution, it's going to travel its circumference. If you have a tire and we mark the edge of the tire, by the time the tire rotates and this mark gets back to where it started, as the tire is rotating and the mark is moving, by the time it goes around once, it has traveled its circumference. So we could say that the distance, how far will it travel? It will be circumference equals 2 pi r, or circumference equals pi times the diameter. And here we already know the diameter, so we'll say 27 pi inches. And that's about 84 inches. So we have the connection between linear and rotational motion is the circumference. So we need to make sure we use this when we're converting from angular to linear and from linear to angular speed. Okay, find the angular speed in radians per second. So now we have to, we want angular speed and we're given the number of rotations per minute. All we're going to do is start with the units that are given and then convert them to the units that are asked for. It's asking for radians per second, so we have to convert that into radians per second. 100 revolutions per minute. 100 revolutions per minute. Our goal is radians per second, so I think that's helpful to start. Make sure you write down what you're given and then write down the goal, and then you can just work on converting revolutions into radians and minutes into seconds. So revolutions, we don't want revolutions, we're going to cancel revolutions, and we want to get to radians. One revolution, we just have to think of, if you go around once, do we know how many radians that is? And yes, it's 2 pi. So we have converted, we have reached the radians, and now we're going to go from minutes to seconds. We want to cancel minutes, and we're going to end with seconds. So 1 minute, 60 seconds. And now we just multiply the numbers on the top and divide by the numbers on the bottom, and we'll get 10.5 radians per second. Same tire. Let's do find linear speed in miles per hour. Find the linear speed in miles per hour if it rotates 3 radians per second. So we are given 3 radians per second, and we're trying to find miles per hour. 3 radians per second. We don't know how much we have to convert. So over here we know we want miles per hour. We need to convert radians, which is rotational, into miles, which is linear. Whenever you see a rotational to linear conversion, then you have to do use the circumference. The circumference is 2 pi r, and that is 2 pi r. This will be inches per revolution. Inches per revolution. It's inches because we were given the 30-inch diameter tire. It's not always inches, it's just whatever you're given. We know that 1 revolution will have this many inches. The circumference is how many inches are in 1 revolution. So now we have this inches per revolution. So we need to go from radians to revolution, and then we can cancel revolution and get to inches. Let's cancel radians, and we need to go to revolution. In 1 revolution, there are 2 pi radians. So now we've canceled radians. And then we're going to cancel revolution, and we know that there are 2 pi r inches per revolution. In 1 revolution, we have 2 pi 30. No, it's not 30. It's not 2 pi 30. It's just 30 pi because it's a 30-inch diameter. So we could say it's 2 pi r or pi d, and this is, we already know the diameter, so we'll put 30 revolutions. We have inches, we need to go to miles. So we're going to go from inches to feet, and from feet to miles. To cancel the inches, we have 1 foot is 12 inches, and we have 1 mile is 5,280 feet. So you have to memorize that conversion. And then we also have to, we've canceled the inches, we've canceled feet, we're left with miles, which we wanted, and now we need hours. We have seconds, we have to go to hours, so we're going to cancel seconds and go to hours. In 1 hour, there are 3,600 seconds. So we've canceled everything, and we'll be left with miles per hour. If we multiply everything in the numerator, divide by everything in the denominator, we're going to get about 2.56 miles per hour. a saw blade rotates at 3,000 RPM, which is revolutions per minute. And then we're going to convert to degrees per second and also convert to feet per second. Two separate problems. So we are given rotational motion, and so to go to degrees per second we don't need a conversion with the circumference, but to go from rotational to linear we'll need the circumference. Pause the video and try that one. So when we need this, we know it's going to be pi d, diameter is 10, and it's in inches per revolution. Let's go with rotational conversion. So we're going to have 3,000 revolutions per minute. We need to go to degrees per second. Revolutions to degrees. So we have to have one revolution. One revolution is 360 degrees. And now we're at degrees. So we've accomplished that. Now we need to go to seconds from minutes. So we're going to have cancel the minutes and we want to go to seconds. 1 minute is 60 seconds. And we have the units that we want, degrees per second. If you multiply, you get 18,000 degrees per second. And then we will convert to feet per second, starting with revolutions per minute. Revolutions per minute. And we want to convert revolutions into feet and minutes into seconds. So revolutions, we have to go revolutions into inches and then into feet. So 1 revolution is 10 pi inches, inches per revolution. And then we have to convert inches into feet. 1 foot is 12 inches. Revolutions, inches, and we have feet. Now we need seconds from minutes. Cancel the minutes. And then we're going to get 1 minute is 60 seconds. Cancel the minutes, and we will be left with feet per second. So we multiply everything in the numerator divided by everything in the denominator, and we get 130.9 feet per second. And that's it for today.